Let's work through one more example, and we'll also try to generate the set of all possible solutions beyond the s and the t that we get. So we recall that the Béziers theorem says the GCD between a and b can be written as a linear combination. Linear combination just means we can multiply and add, and we can generate the GCD. And the hunt is for what are S and T. So the first thing we have to do is, of course, just go through the Euclidean algorithm process. So we begin by saying 2260 equals how many multiples of A, how many multiples of B plus what is the remainder. So if we do a little calculation, we can figure out how many times 816 goes into 2260, which is about 2 times. And then 2260 minus 2 times 816 is going to give us the remainder, which is 628. Now we carry down the 816 and the 628. And now we need to repeat the process. Okay, so 628 is going to go into 816 one time. And then 816 minus 628 will give us a remainder of 188. Repeat the process. 628 equals some number of multiples of 188 plus a remainder. So 628 divided by 188 gives us 3 and some change. So we'll do 628 minus 3 times 188. And that's going to give us a remainder of 64. Again, repeat, 188 equals some number of multiples of 64 plus a remainder. So 188 divided by 64 comes out to just under 3. So it's actually going to go in 2 times. 188 minus 2 times 64 gives us 60. You see we're getting closer. 64 equals some number of multiples of 60 plus a remainder. That, of course, goes into 64 once. 64 minus 60 gives us a remainder of 4. Okay, keep on going until we get that remainder of 0. 60 equals some number of multiples of 4 plus a remainder. 60 divided by 4 is exactly 15. I should have known that. It leaves a remainder of 0. Therefore, our GCD is 4. So the GCD between 2260 and 816 is 4. All right, so we need to figure out what multiple of 2260 plus what multiple of 816 gives us exactly 4. So 4 equals S times A plus T times B. So the first step is to label all of our A's and B's. So here, this is A, this is B. So we're going to replace those with those quantities. And then 816, this is the same 816 that just got carried down, so that is also B. And then all these others are not A, are neither A nor B. The 628 is a remainder. Okay, so first step is to write out the first 2 lines. So what we want to do is we want to solve for the remainder, because remember, we're going to be plugging that in right here for 628. So in the first line, we have 628 equals, subtract away the 2b, so we'll have a minus 2b. Perfect. You can always double check, 2260 in for A, 816 in for B, should perfectly equate out. Do the same thing in the next line. 188 equals B minus 1 times 628. Now, of course, for 628, that's where our first substitution occurs. So for 628, we're going to plug in A minus 2B. So this is going to be B minus 1 times A minus 2b. And again, the purpose here is that every line we're solving for the remainder, and we're always trying to ensure that the right-hand side only has a's and b's in it. So if we combine like terms here, we distribute, we'll get negative a plus 3b. So we'll have plus 2b here. So we'll have negative a plus 3b. All right, so those are the first two initialization steps. Now every line after that, we're going to be making two substitutions. So here in this line, we have 64 equals 628 minus 3 times 188. Now the reason we have two substitutions is because 628 is right up here, and then 188 is the previous line. So we have to make those two substitutions to keep things in terms of a and b. So we get 64 equals a minus 2b in for 628 minus 3 times 188. Okay, 188, we're replacing that with negative a plus 3b. Don't forget the parentheses there. And okay, now if we distribute, we'll get a plus 3a, which is 4a, negative 2b minus 9b, which will give us negative 11b. Once again, at every step, we should be able to verify that if we plug in the a and the b, that in this case we'll get 64. Okay, now next line, solve for the remainder. 60 equals 188 minus 2 times 64. So again, two substitutions here. Use a different color just to make this clear. For 188, what are we plugging in? Well, we have to go back 2 lines for that. There's our 188. For 64, we're plugging in the previous line's results. And so let's go ahead and carry that out. So for 188, I'm putting in negative a plus 3b. For 64, I'm putting in 4a minus 11b. So we have minus 2 times 4a minus 11b. Now we distribute, and we get negative a minus 8a is negative 9a. 3b plus 22b. 3b plus 22b is 25b. Okay, last slide, we have 4 equals 64 minus 1 times 60. And for 64, and backing up 2 lines, we're going to plug in 4a minus 11b. For 60, we're going to plug in negative 9a plus 25b, and we should be done. We'll just check and make sure we did it correctly. So 64, we're plugging in 4a minus 11b. Switch here. 4a minus 11b minus 1 times 60, which is negative 9a plus 25b. By the way, if you in your last line have both coefficients being negative or both being positive, there's likely something wrong. Usually this is going to pan out to be one is going to be, well, both, one of should be positive and one should be negative. So here we get, and I'll just go ahead down 1 line since this is our last one. We have 4a plus 9a is 13a. And then we have negative 11b minus 25b is negative 36b. Okay, well that line right there, that last line, was our GCD, which is 4 equals 13 times a. Okay, well a, remember up at the top here is 2260, minus 36 times b, which was 816. So this should be our S, and this right here should be our T. So let's just double check. We'll take 13 times 2260 minus 36 times 816, and lo and behold, we get 4, so we know that S and T worked out. Now you can, again, check line by line, making sure that you didn't make a mistake, because sometimes you distribute and you end up with a positive instead of a negative mistakenly, so it might be good to just check along the way, but I decided to just wait until the very end here. So at least we know these are correct. Now, these are not the only values of s and t. Remember back up here we said that our little derivation said to generate solutions, find s and t by the extended Euclidean algorithm. That's what we got. That's for k equals 0. Now the other values of or the coefficients that will work will be any s plus any multiple of b, as well as t minus any multiple of a. So we can come up with let's see, s plus any multiple of b and t minus any multiple of a. Okay, so depending on which k I pick, in this case, we start off with k being 0 when we find the original s and t, because you notice that if k is 0, then it's just s and t, which would be 13 and negative 36. If I let k be equal to 1, now perhaps the reason we're doing this is perhaps we want the coefficient of 816 to be a positive number and the coefficient of 2260 to be a negative number, so we can see what happens in that case. Well, s plus kb would be 13 plus 1 times 816. 13 plus 1 times 816. That would be 829. And then t, which is negative 36, minus that same value of k, which is 1 in this case, times a, which is 2260. And we get negative 2296. So the idea here is that if I, instead of using 13, I use 829 times 2260. And instead of using negative 36, if I use minus 2296 times 816, I still get 4 as the result. So that still works out. Now, let's say you wanted this coefficient of 816 to be a positive number. We would actually want to go back the other way, let k be negative. Okay, and now we would have 13 minus 1 times b, which is 816. That would give me negative 803 here, which should then give me a positive number here. So t, which is negative 36, minus negative 1, which is going to give us a positive 1, times 2260 would give me 2,224. So this right here is the first positive value that we can actually have as a coefficient in front of the 816. And again, just checking our work, negative 803 replacing the 13 times 2260 plus t times b. Okay, so that would be, I'm sorry, yeah, plus 2,224 times 816 should once again, if we did this correctly, give us 4, which indeed it does. So that's just how we would then generate results. And again, the purpose of this is, as we will see in a future lesson, sometimes we want one of the negative coefficients that naturally is negative because of the extended Euclidean algorithm process. That's going to give us unique values for s and t, but we may want the signs swapped, so we have to do this generation process.